Okay, so just had a couple of questions about sketching trig functions. So I'm just going to go through 5a and question 6 from Cambridge. So we've got f of x equals sine x, and we've got a domain of negative 2 pi to 2 pi. So let's get a Cartesian plane up and running and yeah, start sketching it. All right, so this one here, because it's going from negative 2 pi to 2 pi, I'm going to draw my y-axis roughly in the middle. Okay, so remember the basic process is what we do is we state our amplitude, which is going to be 1, our period, which we write down the standard period for a sine function, which is 2 pi, and we divide it by the coefficient of x, which is 2 in this case. So a period equals pi. Then we do our scale, which is going to be pi split 4 ways, which is pi on 4. Right, so what I'm going to do is mark the positive x with that, which is 2 pi on 4, pi on 2, 3 pi on 4, and pi, 5 pi on 4, 6 pi on 4, which is 3 pi on 2, 7 pi on 4, 8 pi on 4, which is 2 pi. So that's in the positive direction. So I usually, if I've got to go to the negative side here, I still just do the positive. And then what I do is I, in inverted commas, continue the pattern. So I'll explain what I mean there. So we grab our pen and we note that it's a sine function. Sine starts at the origin. I might just change color on this one. You reckon purple? Have a try that. Okay, and then what sine will do is it'll go up. Okay, so 1, negative 1. So it's going to go up to whatever the amplitude is. Okay, so not to the amplitude. It's going to go up from 0 by the amplitude. So 1, back to 0, there, 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 and there. Okay, so let's do that. Okay, so again, I've explained my issues with drawing trig functions. So hopefully you excuse the crappy drawing, but you get the point. Right, so this is the positive values here. So I've got it going at the moment from 0 to 2 pi. So all I need to do is just continue this back this way to negative 2 pi. So again, I'm going to just continue marking my axes here. So this is pi on 4. This is going to be negative pi on 4, negative 2 pi on 4, which is negative pi on 2, negative 3 pi on 4, negative pi, negative 5 pi on 4, negative 6 pi on 4, which is 3 pi on 2, negative 7 pi on 4, and negative 2 pi. Okay, so what's going to happen here is it's just going to continue down to there, 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 and there. So what should happen is that you just get one continuous wave, okay? All right, so there's our endpoints, so a reminder that they need to be labeled. So that's 2 pi, comma 0, that's negative 2 pi, comma 0, and all of these turning points here are key features, so they would have to be labeled in a test. Generally, we're not going to get you to do, what's that, 4 cycles, okay, but yeah, and all of these x-intercepts here and the y-intercept at the origin will need to be labeled as well. So there's a fair bit of labeling that you need to take care of there. Right, so there is that graph there. All right, now I'm going to clear this off and do question 6. Right, so what we've got here, we want to sketch the graph between 0 and 2 pi, and we want to get the endpoints, which is via f of 0 and f of 2 pi. I don't think we even need to do that, but anyway, so we're going to note that the amplitude is 5 on 2, or 2.5, and our period, let's state the period for a standard cosine graph, which is 2 pi, and then what we're going to do is divide it by n, which is 2 on 3. Okay, and what that's going to do is it's going to be equal to 2 pi divided by 2/3 equals 2 pi times 3 on 2, which is 6 pi on 2, which is 3 pi. Okay, now what we've got to do is get our scale going. So we're going to split the period So it's 3 pi, and we'll go 3 pi on 4 is going to be our scale. Okay, and we're going to go bits from 0 all the way up to 2 pi. Okay, so Cartesian plane, we're going to start it there. Because we're going from 0, we just started at the origin. Okay, so let's mark in our scales. So we've got 3 pi on 4, 6 pi on 4, which is 3 pi on 2, 8 pi on 4, now was it 3 pi on 4, 6 pi on 4, 9 pi on 4. Okay, now let's sketch this for what we have. Now I know that this is going to be an out of domain marker. Okay, so let's just sketch what we've got and see what happens. So cosine will start high. So it's going to start at 0 plus the amplitude, okay, or the translation plus the amplitude. So it's going to go up to 5 on 2. So I'm going to mark 5 on 2 there. And that's where it's going to start at 5 on 2. And what it will do is it will spill down. It's going to go through that point. It's going to come down to negative 5 on 2 down to there. And then it's going to go back up again. Somewhere, well, it'll end up there. But where we want to finish this is 8 pi on 4. So this is 3 pi on 2, which is 6 pi on 4. This is 7 pi on 4. This would be 8 pi on 4. So 8 pi on 4 is going to be roughly here, which is 2 pi. So what we're going to do is chop the graph there. Okay, don't know whether it's going to let me erase it. Let's see. Yes, it will. So I'm going to extend that up to this point here. Right, let's label our key features that we have at the moment. So 0, 5 on 2. This one here is 3 pi on 4, 0. This one here is 3 pi on 2, negative 5 on 2. Now, what's this endpoint here? Well, it happens at 2 pi, and so this is what the hint is. F of 0 and f of 2 pi. We don't really need to work out what f of 0 is, but if we were to do it, that would be the cosine of 2 times 0, which is 0, 0 divided by 3, which is 0. So the cosine of 0 is 1. 1 times 5 on 2 is 5 on 2, as this suggests. Right, so now let's slam in 2 pi into this, and let's just see what happens. I'm going to do f of 2 pi equals 5 on 2 cosine, that's 4 pi over 3. Okay, so what is the cosine of 4 pi on 3? So here's where the exact values start to pay dividends here. So we've got pi there, or 3 pi on 3. We're going to go a bit more than that. We're going to go to 4 pi on 3. So we're going to go pi on 3 more. So that is cosine. That's going to be negative. That's good because cosine is negative there. So what we're going to get is the negative cosine of pi on 3. Okay, so that's what that's going to equal. So it's going to be 5 on 2 times the negative cosine of pi on 3. So that's going to be negative, and cosine of pi on 3 is the cosine of 60, which is a half. So this is going to be negative 5 on 4, okay, which is 1.25, negative 1.25. Sort of seems all right. There's negative 1, there's negative 2, there's negative 2.5. I might have exaggerated the scale just a little bit, but yeah, it's difficult to get this exactly right. So that's going to be when x is 2 pi, y is negative 5 on 4. Okay, and that's our endpoint of the function there. And that is the full sketch over the required domain.